Hey y'all, we're gonna get started in a couple minutes, okay? All right, I'm excited for this. Hey guys. Let me see. Get a little bit of lighting in here. It's kind of dark in the background. Let's see. There we go. It's a little too bright. It's a little better. What if we make it to ShellHacks colors, actually? Hold up. So we have that one kind of like magenta. And then we have this one being like, kind of like cyan. No, that doesn't look good at all. Oh, God. We'll go for it, whatever. Okay, it is 11. We're going to get started in about a couple more minutes just because this is Miami that we're operating from, and we all know Miami time. So we'll give it a couple more minutes, and then we're going to get started, okay? Let me see. Welcome, everyone, to the workshop. Today, we're going to be learning how to use Git and GitHub, two of the most important tools you will ever use for your software development career. So it's going to be good to know. Are we tired yet? It's like 11 p.m. Are you guys starting to feel sleepy? I hope not. There we go. That looks cool. All right, let's see. One request in the queue. What is a queue here? Oh, sorry about that, Antonio. I didn't realize that's what that did. And let's give it till 11:02, and then we'll get started, just to give people a little bit of time to trickle in. Hey, everybody. Thanks for joining the workshop. We're going to get started in a little tiny bit, just to give people time to come in. Hey, everything. Okay, 11:02, let's get started. So before we go, presentation check. Everyone can see the presentation. Everyone can hear me. Everyone can see me, although you don't have to see me for this workshop, but you can see everything, right? Everything looks good? All right, sweet, let's get going. So first off, welcome to ShellHacks. I know it's only been a couple hours, but y'all are in for an amazing time. This is one of the best hackathons you can participate in, and I'm sure everyone's going to walk away from this hackathon learning something. So I'm super excited for you guys. You're going to have an amazing time. So you might be coming in here not really knowing what you're doing, not really knowing how programming works, not really knowing how software engineering works, and that's okay. The whole purpose of ShellHacks and hackathons in general is to learn what's going on and how to be a programmer and how to make a project in general. And one of the biggest and best tools you can have in your arsenal for that is version control, specifically with Git and GitHub. So today I'm going to walk you guys through just a quick workshop for getting acquainted with Git and GitHub, and we're getting really comfortable with these tools that you're going to be using throughout your development careers. So let's get started. So first and foremost, right, what is Git? You guys probably hear Git a lot. You don't really know what it means, but essentially Git is a version control system. And what a version control system is, it's a piece of software that basically takes changes of code that you've written for a project, or not just code, anything really, text files, just files in general, changes that you've made to a project. And it saves versions of that for you. So if you ever make a mistake or you want to go back to a previous version of your project, version control software makes that easy for you, okay? It also allows really easy collaboration, which, think of it this way, if you had to work on a project and you're just sending files back and forth through email, that'll get tired really quickly, and you're going to end up with people working on outdated files really quickly. So version control software is a solution to that. It allows collaboration much more easily, and for tracking changes to projects much more easily. Okay, so now the second piece of the puzzle, what is GitHub, right? So GitHub is a companion website to Git, and it's essentially an online hub for projects made with the Git version control system, right? So one of the main draws of GitHub is it allows for collaboration on large teams, and it's this enormous, huge central repository of millions of different code products, right? So it's the place to be if you're a developer and if you want to have your projects in an official place, right? You back up all your projects online, and then if anything ever happens to your computer, you can just get them from GitHub, right? So for this workshop, first and foremost, I highly encourage you guys, if you want to follow along, to sign up for an account at github.com, okay? It's completely free, should be pretty quick, and that'll allow you to follow through the workshop. And just a quick side note, if you have any questions and you need me to answer anything for you, or you have any help, need any help, you can go ahead and ask a question in the Q&A tab. I'll make sure to check that often just so I can clarify anything for anyone who's confused, okay? All right, so why do you want to use Git or a GitHub, right? It's kind of just like, it might seem like it's a little confusing, not really necessary. You want to just use like Dropbox or something. You don't want to do that, all right? Because it's a very valuable skill to have. It is the industry standard for version control. So there are other version control systems, but Git and GitHub are the industry standard. It's a skill that's basically mandatory for any sort of serious development work. You get to keep all your code and your issues and your documentation in one place. You can keep different branches of the same project, and you can tag significant releases and look at them later. So you have your entire project history stored, and it's just incredibly useful to have as a developer. I've already said this essentially, but I'm going to say it again because it's just to hammer home how important Git and GitHub are. All right. So before we jump into the main body of the workshop, let's talk about a little bit of terminology that you're going to be seeing throughout the workshop, right? So first and foremost, something that you've heard me say already a couple times, and something that's pretty important, is this concept called a repository, right? So in manufacturing and industry, a repository is just a place where you store a lot of things, like an iron repository or an ammunition repository, right? And for code, it's the same thing. A repository on Git or GitHub is a place where you store all your code. It doesn't have to be code. It can be text, it can be images, but usually it's code, right? Now, a commit is a snapshot of your repository at a certain point in time. It is the version in version control. So each commit represents a specific version of the contents of your repository, which means that you can pinpoint exactly what every file in the repository looked like at that point in the commit, right? Now, origin. Origin, remote, and upstream, people tend to get confused a lot, so you might want to pay extra attention here just so you can differentiate between them later. Now, the origin is essentially the URL of the remote repository, right? It's the name of the remote that you are usually working with, right? That represents GitHub, right? This is being recorded, by the way. So I don't know if the chat's being recorded. I think it is, but we don't usually post the chat. So this is being recorded. The slides are going to be published for you guys if you want to look at them later, just so you can skim through and see what's going on. So we've covered an origin. Now, origin is a remote. A remote specifically is really any repository that isn't stored on your machine. So if it's on your machine, it's a local repository. And if it's not on your machine, if it's on GitHub or someone else's computer, it's a remote repository. We shorten that to just remote, right? All GitHub repositories are remote. And then lastly, an upstream. This concept gets people screwed up a bunch. So an upstream is just the tracking information for the branch that we push to whenever we're working with Git, right? The way to think of it, you can think of it like this, right? So when you push code from a Git repository on your computer, It's like you're pushing a barrel off a pier, right? And you're just letting it float upstream, right? But you have to tell the barrel which place upstream it has to head to, because otherwise it'll just float in that stream forever, not knowing where it's supposed to go. So that's what you set your upstream for, so that your code knows where it has to go when you push it, right? Okay, and then lastly, master, or more recently main, is the name of the default branch in a Git repo, right? So whenever you make a Git repo, that's usually just the first branch that you're going to be committing to. So if you don't know what all of the words I just talked about mean, don't worry. I'm going to go through them and I'm going to explain everything, okay? So first and foremost, one of the most important concepts when working with Git is this concept of trees, right? You can think of it literally like you have a couple trees planted in your yard or whatever, and there are 3 main trees that you're working with when you're working with Git. First of all, you have your working directory, which is literally the directory that you have, just all the code you have, all the files, all the resources, whatever you have on your computer right now, that is your working directory, because you're working in it currently, right? The second tree is the index, and that is the staging area, right, that you can add files to, remove them from. And the index is essentially the staging area. It is where your files gather and prepare to be committed to the actual repository, right? And then lastly, you have head. And head is a tree that essentially just points to the last commit made, right? You have the tree that represents your entire repository, and files get moved from the index, the staging area, to the actual repository represented by head, okay? I hope that makes sense so far. So if you want to follow along from here on out, I encourage you to install Git. So for Windows, there is Git for Windows. This URL is right here, and I will try to put the URL in chat. So that is gitforwindows.org. For macOS, it is gitscm.com, and then download Mac. I didn't put a URL, but yeah, that's gitscm.com, download Mac. And then if you're on Linux, then you already know what you got yourself into. You probably already know how to install Git. You probably already have it on your computer. But if you don't, these are the commands you can use. So for Debian, or Debian, I don't know how to pronounce it, you can get it from apt-get. If you're on Fedora, you can use DNF. And if you're on Arch, you can use pacman to install Git. It's a standard package. They're in all the usual package repositories. So when you're installing Git, if you're installing it for the first time, you can just breeze through it, leave all the options as default. The only option you want to change is when they ask for your default text editor, you want to set it to Nano. The default text editor for Git is Vim, which if you're not familiar with it is, let me see, Maxis to download Xcode. You could download Xcode if you wanted to. It's a pretty handy editor. Go ahead and use it if you want, but you don't have to. Anyway, so Vim, if you're not familiar with it, is a console-based text editor. It's kind of hard to use. It's a bit of a pain if you don't know the key combination. So make sure to set the text editor to Nano if you're not experienced with Vim, because it's way easier to use. It's more intuitive. Okay, so now that you hopefully have Git installed, right, let's configure it. So before you commit anything or work on any Git repositories, you have to configure Git just to tell it your username and your user email, because otherwise it'll yell at you. It'll literally tell you, I don't know who you are. Please tell me who you are. Okay? So the way you do that is with the git config command. So once you've installed Git, hopefully you've installed Git by now. Is there a reason not to use VS Code? No, there really isn't. You should probably use VS Code. It's pretty good. I use it. I like it. Okay, so here. So after you've installed, it is correct, Lewis, you're absolutely right. After it's installed, Git and everything is installed, you want to open up the Git bash, okay? And the Git bash is the command line interface through which you're going to be doing a lot of your stuff with Git. So I can open that here just by going into the search menu and typing Git bash. And then that opens up here, right? So now that we have the Git bash open, we can run these commands to configure Git. I'm going to like that comment real quick, Lewis, because you're right. So you can just type in Git, which is the Git command, right? And then Git is just the main parent command from which all of these little subcommands you'll be using, right? So you're going to type the main command, which is Git, and then the subcommand here, which is config. You're going to add the global flag, which is 2 dashes, right? Those are 2 dashes, small dashes. And then you're going to type global because you want to set this globally. You're going to type user.email, and you're going to set your email. I've already set my email for this, but You can type it in quotes. And yeah, so that's how you set your email. And the name is the same concept. So you can set your name, and then you can put your name or whatever your name is, and you can type it in there, and that gets that working. And once you've done that, now every commit that you make with Git on that machine will have your email and your username attached to it. Now, some of you may be thinking, I don't want my real name and email attached to everything I do. Maybe I have specific projects that I don't want that. And for that, you can actually set this locally per repository as well. You just do git config, and then you use the local flag instead of the global flag. You do use quotes. Yeah, Jose. You don't have to use quotes, but in general, whenever you're typing anything with a space in the command line, you want to wrap it in quotes, because otherwise spaces tend to mess up commands, okay? So wrap that argument in quotes. It makes it a lot easier. Those are double quotes, not two single quotes. Double quotes. I'm saying this because every clarification I make is a mistake someone's made before when I've given this workshop before. Okay, so now let's start getting into actually using Git. So we're going to first make a repository. Big idea number one, the git init command. When you're first starting a project, you don't know what you're doing yet. You just want to get something on Git to get started with. Exactly, Parker, you got to use quotes. You're going to use the git init command. So the way you do that is you're going to go into some folder to make, let me see. You installed VS Code, but you can't continue to install Git. Okay, so Salomon, you're going to want to consult with one of the organizers in this chat just so they can help you along. But essentially, you're going to want to go to the website that I put in the chat up ahead, and then just install Git from there. You don't have to install Git through VS Code. You can install it from the Git website. So once you've installed Git and you've configured it, you're going to want to go to any directory. You're going to want to open your Git bash first and foremost. You can do this in the main directory, but you're going to want to create a directory for your repository. So the way to do that in the Git bash is to just do make directory, which is mkdir, and then you can type a folder name. So let's say Git workshop, right? And then we can change directory, which is the cd command, to Git workshop. And now we're in that Git workshop folder that we just created. Ruben, to configure the username, yeah, thank you, Parker. It's git config 2 dashes global user.name, and then you're going to put your name. Okay? So now that we're in the folder that we've just made, it's just an empty folder, we're going to initialize our repository with the git init command. You don't want to do this in like your root folder or your user folder, because then it like makes a repository of that, and that's a mess. You don't want to do that. You want to have an empty folder fresh that you just created for this. That's generally what you want to do. You're going to create the repository, and now you'll see that you've created an empty Git repository, right? So I explained the whole process here. Yeah, so this essentially, you're going to make your directory with mkdir. Yeah, and then you're going to do cd. cd stands for change directory, so that way you're not on your C drive, right? So you're going to make the directory, and then you're going to cd into it, and then you're going to do git init. Can I make the font bigger? Yes, thank you for reminding me. I always forget to do that. Here. So for the record, if anyone's wondering what I just did, if you press Control, hold Control, and scroll, you can actually zoom pretty easily like that. You see? Thank you for the heads up, Jose. Okay, so now that we've created this repository, we're going to want to create a remote copy on GitHub, right? The whole purpose of this is to learn how to use Git with GitHub. How would you make a repository on a different disk drive, Ritam? That's a good question. So essentially, it depends on the command prompt. I'm not going to go too much into that because I want to keep this moving. But essentially, I believe on Windows command prompt, you just type the drive letter for like D or E, and then it'll move you there. And then once you're in that drive, you can type, yeah, exactly, Parker. And then you can type cd into the directory you need to be, okay? So yeah, so we're not going to go too much into that just so we can keep moving. So now we're going to create a remote copy on GitHub. So I have a handy-dandy GitHub right here, right? So let's say we're here. We're going to want to make a repository. And the way we create that remote copy is by clicking this plus button up here in the top right corner. Hi, Nick. Nice to see you. So we're going to click this, and we're going to click New Repository, okay? We're going to fill out the repository details, just whatever you want. So like foobar, whatever. If you're not aware, foobar is kind of like the programmer equivalent of like gibberish. So that's a little programmer joke. And then you're going to fill out the details. You can make a public or private. A public repository can be seen by anybody. A private repository is only by you. and you can add a README, you can add a git ignore. I'll get into these later. It's not really important. You can just create the repository. Boom, just like that. And now you created your repository. So that's pretty sick. Nicely done. That's it. Workshop's over. No, I'm just kidding. There's still more. So now that you've created that remote repository, it's there, but it's not connected to Git on your local machine. You have to connect the two. And the way you connect the two is that you have to add the remote URL here as origin, right? So the way we do that is we go to our command prompt and we're in the repository. You want to make sure you're in the repository. And the way you can tell that you're in the repository is if you see this branch name here, master, show up. That's how you know you're in a valid Git repository. If you don't see this, you want to make sure to create an empty directory and initialize your repository first. And then you can add the repository we just created as a remote by doing git remote add origin. So git is the master command here. Remote is the sub command that deals with anything having to do with remotes. Add is the sub command that adds a remote for a Git repository. And then origin is the name of the remote that we're adding, okay? Origin in this case is just convention. It means whatever remote repository that we're working with, right? And then lastly, the last URL is going to be, the last argument is going to be the URL. So we can get that URL from here. We're going to copy this URL. We're going to go back to Git, and then we're going to paste. So pasting is weird for command prompts. If you're on the default Windows command prompt, the one that looks like this, you're going to paste by right-clicking. If you're on Git Bash, you're going to paste by doing Shift and Insert. The Insert key is in a weird place. If you're on a laptop, you might not even have it, but it's Shift and Insert, or you can just right-click and then paste. And there. Now we've added this remote repository as a remote called origin, right? So now that we've done that, they're connected. So that's it. Exactly. Keyword struggles, I'm telling you. So big idea number 2. Git Add. What Git Add does is it stages changes. It moves them from your working directory, which is the directory you have, just whatever you have on hand, into the index, right? It doesn't commit. It just adds it to the index, gets it ready to be committed. So let's go ahead and do that. So let's add a new file to the repository that we just made. You can go ahead and open the folder in an actual, how can you check if it is connected? You'll know if it's corrected, if it's connected, if you type in git remote and you see origin. If you see origin show up, then that tells you that your remote was created and it's called origin. What do I do if my repository says main instead of master? Don't worry, it's perfectly normal. Newer versions of Git have main as the default branch instead of master to be more inclusive and a bunch of stuff, yeah. So that essentially, yeah, it's a new version of master. So what we're going to do here is we're going to add a new file to the repository. You can go ahead and open the folder in Windows Explorer, and that'll work just fine. But you can also make it in the command prompt if you're like a crazy hacker person or whatever. So I'm going to make it in the command prompt. So in this case, we can just do some sample file, and then we can move this into the center of the thing, maybe get it out of the way a little bit so you can see the slide, and maybe zoom. Yeah, it's fine. And then add whatever text you want, and then Control S for nano to save, and then it's Control X to exit. You see? And now that we've created this file, you can see the file with the ls command. It's in the directory. Now we're going to add the file. That command is with git add, like I said here, main idea, git add, right? So we're going to add that file. The period here is just a wildcard. It adds every file that's not already added in the repository. It's a shortcut. If you only want to add specific files, you can also type out the file name, and that works just as well. So it's going to complain about line endings. You don't have to worry about that. That usually doesn't matter. It's just an interoperability thing. You don't have to worry about that. So you now have the file on your index, and you can confirm it's on your index by using the git status command. And git status shows that the change is ready to be committed. It's on the index, but it's not committed yet. You see? So that's how you know this is here. So next big idea, git commit, right? So git commit is the command that we use to commit to a Git repository. The -m flag here allows you to set a message with the commit that you're making, just so, yeah, Jose, you get out by doing Control X, okay? So this is how you set messages on a commit so that people know what the code you just did was for, right? And that sends it from the index that you've just staged it to head. It's in your repository, it's there, it's set in stone, and now it's part of your history. So let's do that. Let's commit it. So we're going to commit the stuff that we've just added by doing git commit. We're going to add a message. If you don't add a message, then it'll open a text editor and ask you to add a message. It's a little more complicated. It's a lot easier to just put the message in the command, and then I guess just type first commit or whatever. And there you go. You'll know if it worked because it'll look like this. It'll say create mode, a bunch of stuff. You don't have to worry about that. And then there you go. If you haven't configured your Git at this point, if you haven't told Git your username and your user email, it'll complain. It'll tell you to please tell it who you are, and it'll ask for that. So make sure to do the configuration if you haven't already. So we've done it. We've committed a file, but it's still in our local repo. So if we're working with other people, they're not going to see that file in the GitHub repository. So next big idea, git push, right? So the git push command pushes whatever you have on your local repository to the GitHub repository on the remote machine. And there's an optional branch, an optional branch argument that pushes whatever branch you want. If you don't specify the branch argument, it just defaults to whatever branch you're on, okay? So let's go ahead and do that. So we're going to do git push, git being the master command, push being the subcommand with a space in between, the -u flag, which sets the upstream, and then we're going to set the upstream to the origin remote that we just created, the remote called origin, right? So that way when we push our code, it knows where to go upstream. And then lastly, we're going to push the master branch so that Git knows that we want to set the upstream from master to origin, okay? Boom. You only have to specify the whole -u origin master stuff the first time you push for a specific branch. Every time afterwards, you can just do git push and it'll push, okay? So now that's pretty much it. So now it's visible on GitHub. So if we go check on GitHub, you can actually see if we refresh the page, it shows our commit. So that's pretty cool. That's pretty much it. You can see the commit here. It's in the list of commits. It shows when you committed it. It shows your username. And it also shows your email and name if you do the Git Log command. You see, the Git Log command shows you every commit and all that stuff. Let me see. If you got a window asking you to log into GitHub, then that's a good question. Then in that case, you're going to want to log into GitHub because, yeah, that's one thing I forget to mention, but you have to log into GitHub so that Git knows that you are who you are, because otherwise you can just have anyone you want logging into your, pushing to your repository, and you don't want that. Okay, so you're going to want to push, you're going to want to make sure that Git knows who you are, and you're going to want to put your credentials in so that it's the right person. Once you've done that, it should work well, and it'll save your credentials for future use, so you don't have to keep putting your credentials every single time, okay? So Justin, if you're failing to push refs to that link, you're going to want to make sure that you're typing the right branch name. So if you're on main, you're going to want to do git push u origin main instead of master, okay? You can just like fill in the blank there. Okay, so that's it for adding and committing. So for basic Git usage, that's it. You've graduated the basic course. Now we're going to move on to some more advanced stuff, right? So let's get that going. So first of all, branching. Branching is really important, especially when it comes to collaborative work on a Git repository, because it allows you to work on things without stepping on your teammates' toes, okay? So it allows for you to develop your features in isolation without messing with your teammates. So the default branch in Git is master, or like I said before, main if you're using a newer version of Git, okay? And you want to use other branches to work on your features. You never want to commit directly to master unless it's a very small repository or something that it's only you working on a project. If you're working on a project with multiple people, you want to branch and then merge the branch in when you're done, so that way you don't have incomplete, potentially broken code being pushed to master and messing up your teammates, okay? So big idea number 4-ish, I'm going to stop counting them here. Git checkout is a big command here for branching, okay? You can either use it with the -b flag, which creates a new branch and then, which creates a branch and then switches to it, or without the flag, which only switches to an existing branch. Okay, so let's go ahead and do that. So let's create a feature branch for our new repository. So we're going to do git, which is the main command, checkout, which is the sub command here, and then we're going to specify the -b flag, and then we're going to type in the branch name that we want to create and then switch to, because we're using the b flag. So we can just do feature x. We don't need quotes here because there's no space in the argument, and it works just fine. And now we see that the little cyan branch name here is changed to feature x because we are on the feature x branch, right? So now you can do whatever you want to do the repo. So let's say I want to add another file called like, maybe branch file would be a better name for it, right? We can save it, and then we can exit with Control X, and that's how you use Nano. That's pretty much it. If you know how to use Nano from this workshop, you're already way ahead of the curve. Where is the head stored locally? Justin asks. That is a very good question. So I'll go on a tangent right here to explain that, but the head is stored locally in the .git folder, okay? Now on Windows and on most operating systems, this is a hidden folder. You're normally not going to be able to see it, okay? But let me see if I can find the folder real quick. It's in here somewhere. Oh God, it's a mess. It's Git Workshop. Yeah, so you see here, there's a hidden folder. You want to make sure you can view hidden folders. And if you go in here, this is where all that repository information is stored, right? So if you were to delete this folder, it'd be the same as deleting the repository. The files would still be here, but the Git repository and the history would be deleted. So that's where that's stored, in case you're curious. Anyways, if it's asking you to authenticate username and password, you want to enter your GitHub username and password, Ruben, okay? That's how you get that done. So now that we've done that, we're going to add the file that we've just created, git add, and then a space, and then a period to add all the new files. And then we're going to commit the file that we just created to our new branch with the, this message, right? Adding quotes because there are spaces in this sentence that we're using as an argument. And there we go. So if you try to push this right now, you're going to see you're going to get an issue, right? Because remember how I said before, you need to set the upstream for a branch whenever you're pushing it for the first time. So in this case, we've never pushed the feature X branch before. So we're going to make sure to git push, and we're going to use the -u command. You'll see it says -- set upstream here, and that's the same thing as -u. So -u and -- set upstream mean the same thing in Git. Okay, and we're going to set the origin. We're going to set the remote to origin, and we're going to specify the branch as feature X. And now our branch has been pushed and it's stored on GitHub. Okay, so if we go back and check on GitHub, you'll see that GitHub actually lets us know that we just pushed to a new branch, and it lets us click on it to check out the new branch, and you'll see the new branch file is here, right? So pretty useful stuff on GitHub side, right? Can I show what I typed for the commands again? Sure. So for adding specifically, you see, you're going to push, okay, so let me start from the beginning. You're going to check out, you're going to use the -b flag to create the new branch and switch to it at the same time on your local repository. You're going to just create a new file. You can do it however you want, whether it's for Windows Explorer or whatever. You're going to add the new file to your index. You're then going to commit that file from your index to head to your repository. And then lastly, you're going to push it with this command right here, making sure to set the upstream. Is there any way to authenticate the user and password? Yeah, Ruben, it's going to look like you can't type your password, but you can. It just looks like you're not typing anything. So you have to type it blind. That's a security measure that terminals have. I use set upstream here just to show you that set upstream and -u are the same argument. So this is the exact same command as if you use -u. They mean the same thing. Okay? So moving on from here. Now that we've made our branch, it's pretty useful. Now we're going to go ahead and merge them, right? So big idea, git merge, and then you specify the branch. What this command does is it merges the specified branch right here into your current branch, right? So in this case, let's say you want to merge your feature branch into master. the merge command merges a branch into your current branch. So first of all, we need to move over to master. So we're going to check out back to master. You'll notice we don't need the -b flag here because master already exists. We're not creating it. We only need to switch back to it. So we're going to check out back to it, just like we're checking a book out from a library. That's exactly what we're doing here. We're checking the branch out, and we're just pulling it onto our local machine. And then now we're going to do the git merge command with the name of the branch that we want to merge, which in this case is feature X. And now if we look at it, you'll see that branch file has been merged into our repository. And if we look at the directory, sure enough, branch file is here now, right? So big idea right here, really useful command just to show you what's going on with your repository, git log, okay? And that lets you see the git log and work with it. So if we type git log, it shows the log of every commit that you have in your current head, right? So we see the first commit that we committed to master, and we can also see the new commit that we committed to our feature branch that we then merged into master, okay? So it's a really useful command whenever you're trying to troubleshoot or see if a commit was done correctly. You're going to want to use git log, okay? And here I explain a little bit more about git log. There's a lot of different ways you can use git log, okay? If you want to check it out, you can use git log with the --help command or just -h for short, and that shows you a bunch of syntax for git, okay? So I'll bring up the log again just to check. If you see here, there are these long sequences of letters and numbers and hexadecimal next to each commit. This is the commit ID. You can think of it as a version number for your repository, and it shows you where exactly, like which version of the repository this was. So it's a unique ID. It's mathematically pretty much guaranteed to be unique, and you can use this to go back to this commit if you ever have to, which leads me right into, yes, Justin, actually there is. So I'm glad you bring that up. There is a -h for every command. So if you ever get confused, if you ever have to figure out what you're doing with a command, you can, for example, if you forget how to merge, you can do git merge -h or git merge --help, and --help will actually bring up a whole website that has basically everything I just told you, but in way more detail, okay? So I highly encourage you guys to use --help flag if you're ever confused with what any of these git commands do, okay? So back here. So now that we're here, we have the, you here for the PR? Hey, Krista Leon. So now that you have the commit ID here from the git log, right? Let's say, let me segue into another question I see here. How do you switch back to the previous commit? There's a couple ways to do this, right? So let's say we want to go back to our first commit. We can copy this by just right-click and copy. And the cool thing about checkout, the git checkout command, is it also works for commits. So now that we have this commit ID, we can paste the ID here. You don't need the entire ID. You only need the first few characters. And you can now check out this commit, and now you're back at that commit. You see? So it's a really useful way to just go back to the commit, and then if you want to move from there, you can branch from the commit like nothing ever happened, right? It's really useful to have. So let's check out back to master, right? And here we go. The branch is ahead, yeah. So it'll tell you that. So the next useful, let me see. If you want to overwrite a mistake with a previous commit, would you merge them? So if you want to overwrite a mistake with a previous commit, you want to make a new commit that just fixes the mistake of the previous commit, okay? You don't really want to edit history because that messes with Git and it makes it kind of harder to use it, okay? So we're going to keep moving on here because I wish I could answer every question, but we have a little bit more to go to. So, but if you want to branch from this specific commit, you just do the branching, like I said before, git checkout with the -b flag to make any branch. So next big idea, the git tag command. Now, git tag is really, really nice because it lets you, let me just push whatever I have real quick. Yeah, my master, okay. So git tag lets you tag a specific commit with a name so that you can refer to it later and see what, if it was an important commit, for example. So let me, there we go. Let's make this a little easier to see for you guys. Oh, that looks better. So let's say you would do that, for example, for releases or for significant milestones in your project. So let's do it right now. So they show on GitHub, which is a really, really nice part. And they actually integrate with GitHub in a really cool way where you can get, whenever you tag a commit on GitHub, it saves a snapshot of that entire repository as a zip file for you to download if you ever need to get that source code for some reason. So we do it like this. We would do the git main command, the tag subcommand, and then the name of the tag. So in this case, we can just do 1.0.0, like if it's a version. And then we want to make sure to get the commit ID. If you don't specify the commit ID, it'll just tag the most recent commit. Now, in this case, we want to tag the most recent commit, so we can just do that. And there we go. And how do you check if that worked? If you just type git tag without a tag name, it'll list all the tags that you have. OK? So a little bit more about tagging. So tags stay local by default, right? So if you were to push right now, nothing would get pushed because tags stay local by default. If you want to push a tag to GitHub, you have to specifically push tags. You do that with the --tags flag. If you do that, then you'll see the tag gets pushed right here, as you can see here. And then now, if we check on GitHub, you'll see that the tag was actually added here. It went from 0 tag to 1 tag. And if we click on the tag, you'll see the name of the tag here and the source code snapshots. So it's really useful to have for Git. So that's all well and good. You now know how to create your own repository, commit to it, branch and merge, and also tag releases. So now let's talk about using existing repositories. For example, if a teammate of yours created a repository and you want to use that existing repository, or if you're working on a project that already exists from somewhere else, like you're trying to work on an open source project, OK? So in this case, we're going to be using a pre-prepared repository that I made for this workshop. So you're going to visit bit.ly/git-workshop-github, OK? And that will take you to the handy dandy little, it's in here somewhere. Let me just type it manually. Oh, that's all good. Here, let me just copy this real quick. Real quick. Oh my God, what's going on? There we go. OK, cool. So if you put that bit.ly link into your browser, it'll bring you to the example repository that I made. This is a really good opportunity for you guys to see some other nice features of GitHub. I know, right, Kevin? So for example, this is a Markdown file. You can tell because it ends with MD file extension, right? And the nice thing about Markdown files is they're basically just fancy text files. You can edit them in Notepad. You don't need any fancy tools to edit them. And when you create a Markdown file, they actually render, if it's a Markdown file called README specifically, it'll actually show in your GitHub repository as a little info box like this. So it's really nice if you have a README and you want people to see immediately, right? So now that we've done that, let's go ahead and clone this repository to our local machine, right? So big idea here, git clone. The git clone command allows you to clone an existing repository using its URL. So in this case, we're going to copy the URL from here, this URL right here. You don't need credentials or permissions to clone a repository, so you can do it basically whenever you want. You only need permissions to push to a repository. So we're going to go here. We're going to go ahead and get out of the repository we made because we don't want to clobber it with the new repository. So we just get out of here. I have a specific folder for my Git repositories. It's good practice usually to do that. And then we're going to do the main command, which is git. We're going to use the sub command, which is clone, and we're going to type the URL. And now this is going to clone that locally. So we're going to now enter its directory with the cd command, right? The link for the repo is, let me add it right here. That is bit.ly/git workshop GitHub, right? So you can go ahead and follow that. Oh, I misspelled it. Of course I did. bit.ly/ thank you, Rex. Yeah, use their URL because mine was misspelled. Okay, so you're going to go to that URL, you're going to copy that URL, and you're going to paste it in there, okay? And once you've done that, you're going to change directory into the repository that you just cloned, right? Oh, really? I didn't know that, Kevin. That's cool. So the presentation says learning-git. Ignore that. The repository name here is git-workshop, okay? So we're going to change directory, and now you'll see that we're in a Git repository, and you know that because the branch name just showed up. That's one of the nice things about the git bash as opposed to the Windows command prompt. It shows you all this extra info, okay? So by default, when you clone a repository, only master is cloned, and that's just to save resources because you don't normally need every single branch in a project. If you want to use other branches in a project, you can check them out using the checkout command. So in this case, our next exercise is going to involve merge conflicts. So we're going to check out the branch called conflict branch, right? And once we do that, you'll notice if we go back to GitHub, there's already a branch on this repository called conflict branch on the remote repository. So when we check out this branch, since it already exists on the remote, it'll automatically track the remote branch, which already exists as well, right? And now we're going to go ahead and pull the new changes. So the nice thing about remote repositories is that other people can and will update your remote repository. So you always want to make sure you have the newest changes because your local repository doesn't update automatically when you're using Git. You have to make sure to update it manually because you don't want to be working on old code. So you do that with the git pull command, right? Big idea here. Git pull. It fetches changes from the remote repository and merges them into your local repository. So, oh my God. Here. So in this case, we can do git pull, which will pull the current branch. And if you want to pull all the branches, you can just do -- all, and that'll pull all the branches. In this case, it's already up to date, but it'll help if you haven't done that already. Okay, so now let's work with merge conflicts. This is going to be the last major topic in the workshop, but I want you guys to try and merge the conflict branch into master. So to do that, first of all, we want to make sure we're on master because the merge command merges the branch into your current branch. So the way you do that is by, first of all, doing git checkout. We don't need the -b flag here because the master branch already exists. So we're going to go git checkout and switch to the master branch. And now we're on the master branch, you see? And now let's try and merge the conflict branch into master. Okay, ignore that. And you're going to see Git's going to yell at you actually because there is a merge conflict, okay? I set this repository up so that there is a merge conflict. Normally, whenever Git merges a commit, it'll just merge wherever it can, whatever it sees that the histories are compatible, I guess. And compatible meaning that you don't have two people trying to edit the same line at the same time. If that does happen, two branches editing the same line, then you'll get a merge conflict, okay? So we need to resolve this merge conflict. Here. If you're curious, William, why don't you make a README before committing to Git? It just makes it a little bit of a pain. So if you make a README, if you initialize your repository with a README, but you already have code in your repository that you want to push, it makes it really annoying and hard to push because the remote repository already has something in it, but you have completely different stuff. And it basically makes it a pain. So that's why you normally want to create your repositories empty and then just upload what you have. So merge conflicts, right? This is old stuff here. You can ignore this. So here, we're going to be looking at the README file, not ttm.txt. You're going to be looking at the README file. So let's open it up in Nano, and we'll see what we're looking at. Now, you'll see it looks a little bit weird, right? This isn't what we typed. What we typed are these parts here, and these other parts here were kind of just added by Git. And there's a reason for that. It shows the state of each branch, right? So this part up here shows you the state of head on your current branch, which is master in this case. And then this part here shows you what's on the conflict branch, right? Now Git is throwing up a merge conflict here because both of these branches have a common ancestor, right? And then we have a new commit on master, and we have a new commit on the conflict branch. And those two branches are unrelated essentially now that they've edited the same line, right? So that causes a merge conflict. So when this happens, you have to manually edit the file to fix the conflict, right? VS Code also has a way of doing this that makes it a lot easier, but the purpose of this workshop is to show you how it works in the command line, just so you can see how it works here so that it's easier to follow on VS Code. Justin, it doesn't really know what you want to commit because from its point of view, there are two commits that come from the same ancestor. There's a new commit on master, and there's a new commit on the conflict branch, and it can't tell which one you want to keep. So let's say, for example, there's new work on your master branch, but then there's also new work on a different branch. You want to specify which parts you want to keep because otherwise Git would make the wrong decision potentially. So that's why it leaves it up to you. So in this case, the way you resolve a merge conflict is just by editing the file to look like what you want it to look. So we can delete this branch, this line up here because it's just something added by Git. You'll delete this line here. You'll delete this line here. And then let's say I want to keep it saying really instead of super. So I'll delete this line here. And now it looks like what I want it to look like. So I'm going to go ahead and save it, and I'm going to exit. But it's still conflicted on Git. So the way we resolve that, the way we tell Git that we've resolved the conflict is by adding the file again. So we're going to add it with that. And now if we look at the status, we'll see that it's ready to be committed. So we can just commit it with the message merging because it doesn't have to be merging. That's just what I'm putting here. And that commit will be a merge commit that merges those two branches together. You see? And there you go. The conflict has been resolved. So if we look now on our GitHub, we will see that the conflict branch is, let me see. Yeah, also you want to push. So push all the branches. And now if we look on GitHub, you'll see that the conflict branch is now 2 commits behind master, and it's 0 commits ahead. This is a little indicator on GitHub. It tells you where the feature branch is in relation to master. And if we look at master, we will see that the new merge commit is there, and it's merging in the history from both of these branches, the really extra text and the super extra text. You see? So that's how that works, essentially. That's how merge conflicts work. So there's a couple extra concepts let me see. It shouldn't let us do what you did. No, it should let us do what I did. So what I just did was solve a merge conflict, and that's something you're going to want to do a lot whenever you're merging code, especially when you're working with other people, okay? Yeah, it won't let you do what I did to my repository because it's my repository, but this is just to show you, I guess, you're not going to be able to push it. I'm just pushing it to show you that it can be pushed to GitHub, and that's how it'll look, right? You can follow along here. You're just going to have to follow along locally because you can't push to my repository, obviously. So a couple more concepts we do while we're wrapping up the workshop. First big one is the git ignore file, right? So it starts with a period here, and it's named exactly like this, all lowercase git ignore. And what this file does is sometimes there are certain files that you don't want pushed into GitHub, right? Yeah, exactly. I mentioned that, Kev. You want to make sure to specify the M for the message, because otherwise it'll throw you into the text editor. And if you didn't set nano as your text editor when you were installing Git, it'll throw you into Vim, which is really weird and hard to get out of. Retime, yes. For merge conflicts, you have to read through the code and see where they conflict and fix them manually. That's the hard way to do it. Luckily, VS Code makes it easier for you to do that because it automatically just shows you the merge conflicts and lets you merge them with the push of a button. So the purpose of showing you how to do it through the command prompt is just to show you the hard way so you know how the easier way works. You see? So with the git ignore, sometimes there are certain files you don't want pushed to GitHub. So these can be sensitive data like your passwords, binaries specifically, like built versions of your project, because you only want your source code in GitHub. You don't want your executables. You don't want your binaries, just your source code. And also specific user IDE settings, because your settings might not be the same settings that someone else uses, right? So you can make sure Git ignores them by default with the git ignore file. So we can go ahead and create this file in here. If you try to create this file on the Windows Explorer, it'll kind of complain at you just because Windows Explorer, I'll show you what I mean. Windows Explorer doesn't like creating files that start with periods. I'll show you exactly what I mean right here. And it doesn't have a file extension, by the way. So, okay, so I guess they fixed that, so it does work. So you can create it just like that. And now if we go into the git ignore file, right, we check it out, and we can add any files that we want to ignore. So let's say we add a file here like ignore me, that right there. We can actually specify that we want to ignore the ignore.me.txt file in git ignore. And this also works with patterns. So let's say you want to ignore every HTML file in your repository. You can type this, and it'll ignore every HTML repository file in your repository. So that way, when you're doing Git Add, it won't add those to your repository, and you'll keep your repository clean, right? See, so now if we do Git Add and check the status of the repository, you'll see that the only file we're adding is git ignore. That new file is not being added because it's specified in the git ignore. This is a really important part of Git, and you want to make sure to use it just to keep your repository clean. Okay? And lastly, we're going to go real quick just through a couple extra features of GitHub specifically. So Git Add adds the file to the index, exactly. And then Git Commit commits that from your index to your head, which is the actual repository that you have, okay? Hope that makes sense. So some GitHub features here. First of all, GitHub issues, right? These features are unique to GitHub. They don't have any specific, I'm so gassy, equivalents on Git. They're solely for the GitHub website. So first of all, issues. Now, issues allow you to create issues for your bugs or other people to report bugs as well, so that you can be aware of them and you can fix them. You can create an issue with a new issue. Chris, is GitHub Pro worth it? Not really. You don't really need it. So you can create a new issue, and then the issue looks like this. You can add text in it. It's pretty straightforward to use, and people can label it, and it's really nice to use, especially for other repositories to report bugs to people. Secondly, pull requests, right? So pull requests are like merges, but through GitHub instead of Git. So if we have a branch, I'll show you a closed pull request, for example. If we have a branch, let's say we wanted to merge the feature branch into the master branch, we can create the pull request on GitHub, and it's a little easier than doing the whole merging through Git. But most importantly, it allows other people to approve your merge and just check your code to make sure it works well. So whenever possible, you want to go ahead and use merge requests on GitHub or pull requests so that people can see your code and comment on it. Should GitHub Desktop be avoided? No, it shouldn't be avoided. It's pretty good to use. I just show you the Git bash so you know how to do like what every command means, but by all means use Git Desktop for Git Desktop if you want to. GitHub Desktop. I don't use it, but you can if you want, pretty much. After a file is added to the index, how to remove it. I'm not going to go too much into detail because I have a couple more slides I want to cover, but you remove it with the git rm command, right? So you can go ahead and do git rm help to see more about how that command works, okay? And then lastly, forks. Forks are pretty important. So forks allow you to create repositories using others as a base, right? So let's say you find a really cool project on GitHub and you want to work on it, but obviously you can't contribute to the original repository because you don't have access. What you can do is create a fork, and then that fork basically clones the repository in GitHub and makes it as if it's your repository, your own separate copy of it, right? So you can do that by just cloning any repository. Let's just grab a random one here and then fork this into our namespace. And now it's like it's our repository. We can commit to it. And the nice thing about pull requests that I didn't specify before is that not only can you merge branches in your own code, but you can actually also merge your fork into the original repository. So let's say it's an open source project and you're working on some improvements to it and you want to merge your fork back into the project, you can do that with a pull request. you see here the base repository is the base one that we just forked from. And then this head repository is ours, you see? And of course, you can also just merge into your repository as well if it's just a regular merge request for branches. How is forking different from cloning? Good question. So cloning clones a repository into your local Git repository, essentially. And then forking gets that repository and forks it onto GitHub, so you don't have to go through the whole process of adding the remote and pushing to the remote. It makes it a lot easier for you. It's kind of like a shortcut in that way. And can everything I've done in Git Bash be done in GitHub? Almost everything. So there's no really easy way to add files and edit files in GitHub. That's meant to be done through Git, okay? But almost everything else I showed you, like merging through a pull request and all that good stuff, you can do through GitHub. So that's just to show you real quick. So that's the workshop. Thank you guys so much for coming. If you want to learn more about Git, there's a bunch of other stuff you can learn about, like cherry picking and a bunch of other important stuff, and patches and stuff. And you can learn that with these links here. So I will go ahead and actually put these links in the chat. Thank you guys so much for coming. I hope you learned something, and I appreciate y'all. So thank you. I will post the links. This workshop will be recorded, and the slides will be shared if you want a little something to refer to while you're working on your projects. Oh my God, please, just thank you. Here we go. I hope my workshop was actually useful. Not to say other workshops. Of course, Yasmin, thank you. Here, this isn't testing, but how do we access the recordings and slides? That's a question for Yasmin and Kevin. So this isn't letting me copy this for some reason, but that's awkward. I can just do this. I can, oh my God, please just behave. I'll just post the first one because the first one's really useful. And here you go. All right. Thank you all so much. Have a good hackathon and knock it out of the park. You guys are going to do great. I already know it. I am so excited for you guys, and I hope you have a really good hackathon. All right. OK, so Kev, I'll go ahead and send you these slides just so you can see them. I'll just like Discord them to you or something. Here. All right. I'm going to stop sharing my screen. I'm going to stop showing my ugly face, and I'm going to, there we go. Yeah, I know I'm still here, Drago. Don't worry about it. All right. Thank you.